So now let's look at writing some ionic compounds, and these are going to contain some polyatomic ions. So the first one we're looking at is strontium phosphate. And so if you look up strontium, strontium is an alkali earth metal. It's got a charge of +2. And then we have phosphate. Now if you look, phosphate ends in ATE. Most of the polyatomic ions either end in ATE or they end in ITE. You got a lot of 8s and a lot of ites. Most of the simple negative ions, the monoatomic ions, those end in IDE. So this ends in ATE, so it's going to be a polyatomic ion. So you look on your ion sheet, and phosphate is PO4, and this has a charge of -3. Now, the total charge has to add up to 0. So we have two strontiums. The strontium has a charge of +2, phosphate's -3. When you see 2 and 3, you think smallest common multiple is 6. So we need to get to 6 for strontium. We need 3 strontiums. 3 times 2 is +6. For phosphate, to get to -6, we need 2 phosphates. Now, whenever you need more than one of a polyatomic ion, you have to put it in parentheses, because phosphate's formula is PO4. So if I can show you this down here, if we don't put the parentheses and we just say I need 2 phosphates, well, written like this, you don't have 2 phosphates. You have 1 phosphorus and you have 42 oxygens. So you have to have the parentheses. This means 2 phosphates. So anytime you have a polyatomic ion and you need more than one, it has to go into parentheses. You can never change the formula for phosphate. So 2 phosphates will give us -6, and that will add up to 0. So then we need to write this and make this nice and pretty. So we have strontium 3, we have phosphate in parentheses, and we have the 2 outside. Sorry, that's kind of ugly. So 3 strontiums, 2 phosphates, that adds up to 0. So this is the formula for strontium phosphate. Let's look at another one. So let's write the formula for zinc acetate. So zinc, the formula for zinc is Zn. Zinc is in the D block. Anything that's in the D block could have more than one charge, but zinc is one of those D block metals. It just has a charge of +2. Acetate, now acetate doesn't sound like any of our regular elements that turn into an ion. It ends in ATE, so it's a polyatomic ion. And if you look acetate up, the formula is C2H3O2, and then the whole acetate has a charge of -1. So zinc is +2, acetate's -1. So how many acetates do we need so this adds up to 0? Well, if this is +2, we're going to need 2 acetates, because 2 times -1 will give us -2. This zinc is +2, so that will add up to 0. So our formula is ZnC2H3O2 with the 2 outside. There is zinc acetate. Let's look at one more example together. Copper 2 chlorate. So copper 2, symbol for copper is Cu. This Roman numeral 2 tells us it's got a charge of +2. Chlorate, it ends in ATE. So this isn't chloride, it's not Cl negative 1. So we look up chlorate and we find it, and chlorate is ClO3 negative 1. So chlorate is made up of 1 chlorine and 3 oxygens bonded together. So copper's plus 2, chlorate's negative 1. So, oops, let me put this back. Fix this up a little, sorry. So chlorate's negative 1. So we need 2 chlorates to cancel out this plus 2. So parentheses, anytime we have more than one of these, we need parentheses. So we got plus 2 minus 2 is going to be 0. So we rewrite this CuClO3 2. There's copper 2 chlorate.